Hey guys, in this example, I'm going to show you how to tackle one of the cone problems. So the very first thing I'm going to do is, I'm going to draw a cone. Boop-boo, boop-boo, boop. And now I'm going to mark up the text. I'm going to write all the important things, underline all the important things, and describe what they are. So now that everything's underlined, let's write the appropriate notation for everything. Flowing, so I know that this problem is going to be talking about water flowing into a tank, so we're going to be dealing with volume. And since it's flowing into the tank at a rate, I like to circle the word rate, of 5 cubic inches per second, I know that the derivative, rate means derivative, right? So I know that the derivative of that volume with respect to time is going to be equal to 5 cubic inches per second. Cool. We're going to talk about what to do with all that stuff in the red box in just a second. It says, how fast is the water level rising? So how fast, I know that's another rate, so it's another derivative. And water level rising, I'm going to use a little h to talk about the water level. You know, the height of the water, I'll use a little h. So since it's how fast, we're talking about the rate or derivative. So dh dt is what we're trying to find. When the water is 2 inches deep, so when the h is equal to 2, the little h is equal to 2. Now real quick, I'm going to explain what to do with this red box here. There's, in all these cone problems, this altitude of 4 inches, I guess I should have included altitude in my box, and base radius, those all serve the same purpose. So base radius, so there, I'll give it a big R equals 3 inches, and a height, so I'll give that a big H equals 4 inches. So in all of these cone problems, that big R and big H serve one purpose. I'll explain it very soon. I'm going to finish decorating my cone here. There's the water level, and I said I was going to use a little h to talk about the water level. Little h equals 2 inches. So, and I'm trying to find dh dt at that moment in time. Alrighty, so the formula we're going to use for this guy is going to be 1/3 pi r squared h. Now the problem is I have a lot of information that tells me about this little h, the height of the water, and I know that I'm trying to find the rate of change of the water level, but what I don't know much about is this little r here. I don't know what the radius is. I know you guys are smart and you could probably figure it out real easy, but I wouldn't know what dr dt was either. So because I don't know much about r or dr dt, I'm going to use a ratio, this big R and big H has a ratio of 3 to 4. So I'm going to use that 3/4, the base radius and the altitude, to rewrite R in terms of H. And you could do that super fast, just R equals 3/4 H. I'm going to use a little h when I plug it back in, but I just wanted you to understand that the big H represented the height or altitude of the cone, and the big R represented the radius of the base. So now that I know that, I can replace R over here with 3/4 H. Volume equals 1/3 pi, and instead of R, we'll have a 3/4 H in there. 3/4 H. So what's cool about that is after I simplify, I won't have to use, I would have had to use product rule up in here. I don't have to do that now. So let's simplify real quick. 1/3 pi. Remember that everything in these parentheses is going to be getting squared. So 1/3 pi times 9/16 h squared times h, which is what? 1/3 times 9/16 is like, what is that, 3/16? Pi h cubed. Cool, a much simpler version of the formula with only one variable. And remember, we had to do that because we didn't know much about r. So we had to rewrite r in terms of h. Alrighty, and from there I can do my calculus. So my calculus would be the derivative of volume, dv dt. And I have a constant multiplier of 3/16 pi. So 3/16 pi. And then the derivative of h cubed will be 3h squared dh dt. Cool. I'm going to go ahead and... I guess I'll simplify it a little bit. dv dt equals 9 pi h squared dh dt over 16. And now I'm going to substitute and figure out what dh dt is going to be. So dv dt, we said it was 5 up at the top. 9 pi. At this moment in time, h is 2, so I'll have 2 squared dh dt all over 16. A little bit of algebra 1 here. 16 times both sides gives me 80 equals 9 pi times 4, so 36 pi dh dt. And let's divide by 36 pi, and I see that dh dt is equal to 80 over 36 pi. I can reduce that, divided by 4, what is that, 20 over 9 pi. Units would be, let's see, h was measured in inches, time was measured in seconds, so it'll be inches per second. What that means to us is that our water level is increasing at a rate of 20 over 9 pi inches per second. The end.